So good morning students, we are back here again with one more new video. So we are going to begin with a new chapter today, that is the halogen derivatives of alkanes. Halogen derivatives of alkanes. So my dear students, in the last year in the 11th standard we had learned one chapter. The name of the chapter was hydrocarbons. So you might be remembering it. In the hydrocarbons we had learned about the alkanes, alkenes and alkynes, right? So what is exactly hydrocarbon? So hydrocarbon is nothing but the compounds formed by the combination of a carbon and hydrogen. So what is hydrocarbon? Hydrocarbon is nothing but formed by the combination of carbon and hydrogen, right? So these are very important compounds. This combined to make the hydrocarbon. Now why this hydrocarbon is required? Because this hydrocarbon is the base for this halogen derivatives of alkanes. See the word itself, alkanes. Alkanes are coming under the category of hydrocarbons. That is why studying this hydrocarbon is very important. So this is the base of this chapter, hydrocarbon. Now this hydrocarbon can be classified into three types. You already know it, but I want to repeat it once again so that the concept of the hydrocarbon will be very much clear. If the concept of the hydrocarbon is clear, we can proceed further for the halogen derivatives, right? Okay, so here we can say hydrocarbons are classified as alkanes, alkenes and alkynes, right? So you all know we had studied what is alkanes. What is alkanes? Where there is a replacement of a ane. In alkenes there is a ene, and in alkynes there is a yne, right? So you will write, you can note it down. This is ane, this is ene, and this is yne. Now what is the major difference between this? Alkanes contain single bond. They contain a single bond. Alkenes contain a double bond. And alkynes contain the triple bond. Triple bond. So this is very important. Last year we had learned about the bonds also. You might be remembering it. Single bond, double bond, triple bond. Right? Single bond is formed, which is formed is also called as the covalent bond. Right? This single bond is also said to be a sigma bond. It is a very strong bond. Then coming to this double bond. See, in double bond there is a 1 sigma and 1 pi. 1 sigma and 1 pi bond. In case of a triple bond, there is a 1 sigma and 2 pi bonds, and these pi bonds are considered to be a very weaker bonds. I hope that you might have understood this concept. Okay, now from this particular alkanes we can prepare the haloalkanes. See, from alkanes we can prepare the haloalkanes. From alkenes we can prepare the haloalkenes. And from alkynes we can prepare the haloalkynes. Are you understanding, my dear students? See, this is very simple. From alkanes you can prepare the haloalkanes. From alkenes you can prepare the haloalkenes. And from alkynes you can prepare the haloalkynes. Right? So here let's understand what is exactly haloalkanes, haloalkenes and haloalkynes. So for this we have to first understand what is exactly the word halo. So here the word halo, H-A-L-O, halo stands for halogen. Word halo stands for halogen. Now halogen is represented by the X, and this X can be fluorine, chlorine, bromine, iodine. So any halogen atom may be present, but that particular halogen atom is represented by the halo, that is X. So remember, whenever you see X, you have to remember that any particular halogen group is present in the given compound, right? So here in this case, now what is alkyl group? You also have to understand the alkyl group. See, this is CH4. Are you understanding? This is CH4. What is the name of this compound? Methane. So when one of the hydrogen atom is removed from the methane, it gets converted into CH3. Are you understanding it? अगर मैंने एक hydrogen निकाल दिया तो what will happen? CH4 will get converted into CH3. Now this is alkane. Are you understanding? This is alkane. But alkane is getting converted into alkyl. Now this becomes the alkyl. Right? So now this particular alkyl group is represented by R. Are you understanding? It is represented by R. And when the bond is formed between this alkyl and this halogen, it is represented as RX. RX. That means alkyl halide. See, halide is nothing but the other word for the halogen. Remember, what is halide? Halide is nothing but the other word for the halogen. When a particular single halogen atom is present, we say it is the halide. So this becomes your alkyl halide. So any alkyl halide may be present. For example, it may be, let's take the example. We can take CH3Cl methyl chloride. It may be CH3Br methyl bromide. It may be CH3I methyl iodide. Right? Not necessary it will be only methyl. Ethyl group can be also present. C2H5Cl ethyl chloride, C2H5Br ethyl bromide, C2H5I ethyl iodide. So this particular compounds are very important compounds. We are going to study their physical properties as well as their chemical properties, and their preparation methods are also very important. And in the board exam, most of the time the questions are asked on this particular alkyl halides, right? So I hope that you are understanding, my dear students. Okay, now we can take the example of the haloalkanes. But before taking the example of the haloalkanes, we have to understand that what is exactly halogens and where halogens are placed in the periodic table. So let's go for the periodic table. So this is our periodic table. See, this is, I'm just drawing a rough diagram of the periodic table. This is the S block, this is the D block, this is the P block, and this is the F block, right? So you all know that our periodic table is divided into 4 parts: S, P, D and F, right? So here in this case, our halogen atoms are placed in group number 17, that is the fluorine, chlorine, bromine, iodine, astatine. This is the group number 17. So it is very important. It is placed in the P block. The question can be asked, where is the placement of the halogen atoms in the periodic table? So the placement is in the group 17 of the periodic table, right? You have to understand the difference of the groups and periods. Last year we had learned the chapter periodic table. In this particular chapter, I have taught you each and everything how to read the periodic table, right? So you have to refer this particular periodic table chapter to understand the placement of the halogens. Okay, now let's move further. Let's take the example. One by one we'll take the example of a haloalkanes. Okay, now in this case of a haloalkanes, I can take the example of CH4. Right, now this is a methane. Now when I take out one hydrogen atom from the methane and replace it with chlorine atom, I'm replacing it with chlorine atom, it becomes the CH3Cl methyl chloride. When I take out one more hydrogen atom and replace it with chlorine, it becomes the CH2Cl2, right? You can also write down the name methyl chloride This is dimethyl chloride, or we can say dichloromethane. This is the name, right? Then when you replace one more hydrogen by the chlorine, then it becomes CHCl3. What is the name of this compound? Chloroform or trichloromethane. Right? Then when you replace one more hydrogen with a chlorine, then it becomes CCl4. This is the carbon tetrachloride. Which is very, very important. So here this is particular CCl4 is used as the solvent in many reactions. Then CHCl3 is a chloroform. It has a wide application in the medical field. Then methyl chloride and dichloromethane are also very useful, and the reactions of this particular things are asked many a times in the board exam. So this is about the haloalkanes. Mostly in this particular chapter we are going to focus on the haloalkanes only, not on the haloalkenes or not on the haloalkynes. Are you understanding? We are not going to focus on the alkenes or alkynes. We are only going to focus on the haloalkanes. Now here in this case, we also have to understand that what is this two words, saturation and unsaturation. Now what is the saturation and unsaturation? So last year you had already learned what is saturation and what is unsaturation. See, saturation means what? Containing single bond. There is no any presence of a double bond is there. That is what is called as the saturated compound. There is no presence of a double bond. There is only a presence of a single bond. It is said to be a saturated compound. Now what is the unsaturation? Unsaturation means compound containing the double bonds are said to be the unsaturated compound. Are you understanding? Saturated and unsaturated compounds. So we are going to see the saturated as well as the unsaturated compounds in both the cases. Okay, now here we also need to understand what is the aliphatic and aromatic. Difference between this. What is the aliphatic and what is the aromatic? Now what is aliphatic? Aliphatic compounds are those which are containing the straight chain. What is aromatic? Aromatic compounds are the cyclic compounds. Example is benzene, then we can take cyclobutane, then we can take cyclopentane, right? So this can be examples of the aromatic. Now this particular aromatic can be proved by the Haeckel's rule of aromaticity. So this particular Haeckel's rule we had learned in the 11th standard. What does this rule say is that any planar cyclic molecule which follows the 4n plus 2 pi rule is said to be aromatic compound. Right? So last year we had learned this in the chapter aromatic compounds. So you have to remember this. What is the aliphatic and what is the aromatic compounds? Okay. Then here I am also supposed to tell you one more basic thing in this chapter, that is the haloarenes. Now what does this word arenes mean? Arenes are nothing but the aromatic compound. See, aromatic compound I already told you. Aromatic compounds are nothing but the cyclic and the planar compounds, and aromatic compounds are those compounds which have a specific odor or a specific smell, right? Or they have a very sweet smell. That is why this word itself means aroma. Aroma means which is containing a sweet smell, right? So this compounds also we need to see. For example, this is our benzene. This is the hydrogen atom of the benzene. So when you replace one of the hydrogen atom of the benzene by the chlorine, this becomes the haloarine. What is the name of this compound? This is chlorobenzene. Chlorobenzene. This is benzene and this is chlorobenzene, right? Are you understanding, my dear students, what I am trying to tell you? That we can prepare the halogen derivatives from the hydrocarbons, that is from alkanes and as well as from the aromatic compounds. So they are nothing but the derivatives of the hydrocarbons. So this is a very basic of this particular chapter. Then in the next class we will go for the classification of the halogen derivatives. So it is enough for today. We will meet afterwards.